Okay. Hello, everyone. My name is Andrew Kyle, and today I'm going to be talking about the ethics of ceramic matrix composite additive manufacturing. So let's begin. Uh, Okay. So to go over a little plan of how we're going to go about this, we're going to first discuss about what are ceramic matrix composites. Then we're going to show the importance of them to the industry as a whole. Next, we're going to talk about the technical challenges associated with 3D printing this type of material in general. And finally, we're going to go over the results of that and how the ethical implications of the technical challenges of it. It's pretty much, they go hand in hand with each other in this case. So to begin, what are ceramic matrix composites in terms of additive manufacturing, or as you know it, 3D printing? So we're actually going to start with talking about what additive manufacturing is and then go into how ceramic matrix composites work. So 3D printing is you take a simple plastic polymer, it's usually like a ream of filaments that goes into an extruder, heats up to a very high temperature, and is printed out layer by layer on a surface and then it pretty much builds up into a full part. Now, taking that into ceramics matrix composites are basically a ceramic polymer that are integrated with fibers to create a really reinforced, strong material that is very industry level prepared compared to, say, a cheap plastic that will break at the snap of blade if you just crack it. These are extremely tough and durable and can handle the most intense what's it called? The most intense just environments as a whole, like such as heat. Like they can heat up to 1500 degrees Celsius without melting. They are incredibly durable and are designed for the most tough environments. So what are their applications? So to begin, there are several applications currently for ceramic composites. These aren't necessarily used by additive manufacturing yet, but they're in process of becoming usable by additive manufacturing. So we see them used in customized prosthetics. They're used for hip joints, dental implants, actual prosthetic legs in total. And the uses with additive manufacturing is that it will become way easier to design and create these parts rather than the typical means because of how, what's it called? Because of how customizable they are per person. They need to be very specific per person, and additive manufacturing will make that a lot easier. CMCs are used in turbine blades and jet engines because of their good heat distribution. They will be able to conditions and not not need the amount of cooling as say different component like different types of materials in jet engines. And finally, ceramic car brakes. Now this is more found in a lot more hypercars. They're a lot more technical and efficient in braking, which is why you see them in a lot more advanced cars. But in the future, with additive manufacturing and the process becoming a lot easier to create these ceramic brakes, they might be found in a lot more common cars such as Fords, Chevrolets, things like that. So the reason why this is so important is there is a huge market for CNCs and they are only increasing. In 2021, they were estimated to be worth a $3.2 billion in the entire industry. By 2030, they're projected to triple that size. It is a rapidly growing market and they are very useful in so many different industries, biomedical, mechanical, aerospace, all of these different types of industries are extremely important to the uses in these industries. And we can see that obviously they're going up and becoming more and more useful in the industry as a whole. So what are some pros of at CMC additive manufacturing compared to previous technology? So let's go into the previous technology that was used to create ceramic matrix composites. So first we have is injection molding. Now injection molding, you have to create a complete housing for injection molds, which is very cost inefficient. And if you want to make any slight changes to the design you use, you have to redesign the entire mold, which is extremely inefficient in cost. The other is subtractive manufacturing, which is the opposite of additive manufacturing. You take a block of ceramic and You literally chisel around it. A machine chisels around it to create a part, which becomes a lot more limited in terms of complex geometries per se. As additive manufacturing, you build it up from the ground up, so you can create a lot sharper edges, a lot more complex infills and inner geometries that you would not be able to find with subtractive manufacturing or injection molding. Now, on the other side is better efficiency. So, because, for example, subtractive manufacturing cuts away at materials and injection molds need all of these different types of molds to begin with, you have a lot of material use. Additive manufacturing cuts that down tenfold. The time is also reduced effectively because you don't have to create these different molds. It's just built from the ground up every time. The design is far easier and simpler to maintain and develop for making an additive manufactured parts. And also just any design changes just are they're just easier in general. So it creates unimaginable efficiency increases. Now, some of the current cons with CMC additive manufacturing. It's a new technology, so there's a lot of issues with failure points in the material, in the structures of the parts that are being printed. Porosities, because compared to, let's say, traditional additive manufacturing with a plastic filament that you can just run through and heat up to a high temperature, the initial material of CMCs is very viscous. So it forms bubbles and inconsistencies in layering that causes a lot of part failures, cracks, all of these different types of things that would be very, say, yeah, so coming in. Sorry, no, you're all good. So we have a lot of inconsistencies and part failures that can be very detrimental to the uses that they have. And all these things can be very difficult to deal with. So from that, we can go into the ethical implications of this. According to the ASME Code of Ethics, the first fundamental canon says that engineers should hold paramount the safety, health, and welfare of the public in the performance of their professional duties. Now, what this means in terms of CMC additive manufacturing is with these part failures that we have, that could be very detrimental to the uses that they provide. For example, you can't have a failure in of a jet engine, as it will cause a crash that could be potentially complete or most likely, most definitely fatal to the user of the jet. Or the ceramic bake failing can result in a car crash. Things like that are we have to avoid at all costs, and we have to take the measures to do vigorous testing on these different types of parts in order to prevent any types of injuries occurring. Rigorous testing and implementations of these different types of testing and safety precautions is necessary to be able to commercialize this product. Now, on the good ethical implications, the eighth fundamental canon says that engineers shall consider environmental impact and sustainable development in the performance of their professional duties. Now, with the old methods of injection molding and subtractive manufacturing, that was very resource inefficient, cost inefficient, time inefficient. It was all these different types of things. With the new methods that are currently in development, such as liquid polymer infiltration, chemical vapor infiltration, and polymer pyrolysis, these are a lot more conserving resources, conserving time, and overall being more sustainable to the environment because of these conserved resources. So in conclusion, ceramic composite additive manufacturing offers high potential in its efficiency and environmental contributions, but it also supplies a lot of technical and ethical hurdles that we have to overcome as engineers. Success in the industry is completely dependent on professional integrity, testing, and integrated engineering. The industry in general will be revolutionized by the use of ceramics in additive manufacturing, as the importance is just incredibly extreme. Thank you. Do you guys have any questions for me? Anything?
I got you. So you said something about the holes in like in the material, or whatever. Is there a way to prevent that?
So that is currently being developed. The process of it is being developed to be able to minimize the pores in it. It's basically just completely determined by the type of material you put into it. It's a lot of materials engineering and being able to develop the type of material that would restrict the type of porosity that you would have. The different types of additive manufacturing that I mentioned, it's they're those are all determined to minimize the effects of that. Same with the inconsistent layering and the potential shear cracking across the layers is something that is just being worked on in different means of being able to, make these products accessible or commercializable. Anything else?
What's your personal take on it? Like the use of it versus not? Like,
Oh, it needs to be in the
okay.
industry. I feel personally that the benefits of having it will be extremely beneficial to so many different industries. Personally, defense especially being able to 3D print turbine blades for jet engines or heat shields for aeronautical, like what's it called? Like spacecraft. Currently testing with like NASA is currently testing ceramic based heat shields that are 3D printed. It's the industry, it's going to completely revolutionize so many different parts of the industry. Evans.
I'm in the wrong room. Sorry, guys. I think I let you finish.
Oh, I appreciate that.
Yeah.
You're all good. We thought you were the last person. We were missing someone.
Listen, who is this guy? Yeah.
It was kind of nice. I had a timer on my screen.
Yeah.
I could see it. I didn't know that at first. I'm sorry.
She said that and watched. Yeah, that's my sister. Hopefully, you learned something. Probably going to something like this.
Yeah. Probably.
Everyone's in another group. Yeah.
Everyone's doing it today.
Yes.
Thank God I'm done. How'd y'all think of that? Too fast, too slow?
That's pretty sure, man. Yeah. I'm used to
I'd wait till you upload whatever you have before you unplug that because
I'm scared. I'm scared to unplug. That's why.
thankfully it saved everything.
It's currently recording. I'm so are you going next? Yeah. Okay, so you start this, you share your screen, and then you click more and record, and it's currently